Alright, gonna be teardown review time today. And this is the auction. It's the SMD 2-in-1 862D Plus soldering iron welder hot air gun rework station plus accessories. Paid $52, and that's from Buyco UK store. So let's see what we get in this generic cardboard box. Right up on the top, and you got like a plastic tube with a screw and a piece of little metal thing in it. Got the hot air tips, a couple soldering iron tips. It's nice that they give you more than just the standard pencil tip. The pencil soldering iron, and looks like the gun for the hot air. Okay, I've got the main unit. It looks blue on the camera screen, but it's actually kind of like an indigo, almost purple color. It's actually pretty heavy. Looks good so far. And then we got the mounting bracket for the hot air gun. Stand for the soldering iron, and that's it. It comes with a sponge. First things first is the cord feel. It's pretty flexible. It doesn't have like the super silicone feel of like a, your typical more expensive soldering station. Okay, so before I go plugging this thing in, let's take it apart and see if I want to trust it. Alright, so what is inside? Okay, transformer looks pretty decent. Alright, so mains power comes into the unit. Got like a little splice there, but they've actually got some kind of like Loctite on the nuts for the fuse holder, and the fuse holder contacts are actually heat shrunk. So far so good. The ground connection's crimped, I think. Nope, that's actually just soldered. And they didn't do a very good job at it. I mean, I'm sure it'll work. It's just not the best. And then they've got the main circuit board. They got glue on all the, they got like Loctite glue on all the circuit board connectors. Looks like the main microprocessor is actually socketed. And right in here it looks like they had a little rubber boot that kind of slid off one of the main power switches, so I'll stick that back on. Now, since this is the wires going out to the hot air gun, it looks like they're actually sending 120 volts out to that. Well, I was trying to remove the PCB from the front panel, but I don't seem to have the correct size Allen keys to remove the potentiometer knobs. But I'm not seeing anything of crazy, scary quality-wise on the circuit board, so I think I'll hook it up and see how well it works. Alright, so the unit's reassembled. Let's take a quick look at the insides on the hot air gun. Let's see if they've improved the design on these things at all since the cheapo hot air station I saw Dave review on his EV blog channel a few years ago. The one he did was just the hot air station. It wasn't a soldering and hot air station. There we go. Okay. Yeah, see, they didn't take any chunks out of the fan like they did in the one Dave showed. That all looks fine. Circuit board looks fine. And there we got ceramic heating element with the thermocouple. And we got ground lead. It's actually crimped on there. That looks pretty good. No complaints there. Okay, next up is the actual iron. And I already disassembled this before, and I found something not so good. Look at how much this tip wiggles. It's so loose over the ceramic heating element, it's going to make terrible heat, thermal transfer to the actual element. So, is it the tip? Here's a tip from my other soldering iron that's pretty good. And it's a little better, but it definitely still wiggles quite a bit. Let's see, I can see it a little better that way. And if we compare it to my Radio Shack soldering iron, which is still just a another clone, I believe, of the original Heiko's, but if you take this one apart, that tip almost doesn't wiggle at all. Ideally, it should almost be like a a stiff friction fit, so that you could get that good metal to metal or metal to ceramic contact, and get that heat from the element to your soldering iron tip, because there's no sensor in the tip. The sensor's in the heating element. So even if the heating element's up to temperature, your tip probably won't be. So that's my first real major complaint about this thing. Alright. Let's hook it all up and see how it goes. Alright, now here's something interesting. Both switches are off. Now I'm going to go plug the station in and listen carefully. You can hear the transformer thump, which means it's energized all the time. Alright, so what does this thing actually consume when it's even turned off completely? Amps, watts. So this thing's actually drawing 6 watts continuously turned off. VA, power factor 0.6, 80 milliamps. Alright, so let's actually turn on the soldering iron. 100 degrees. And it's ramping up. That was pretty quick. Huh. Interesting, you can actually hear the transformer when the iron's running. Alright, so we'll ramp it up. .300 degrees. I'm liking how fast the display updates. It's smoking. Yep, it's not already melt solder, that's pretty good. Okay, dug a random circuit board out of my junk bin. In this case it's a double-sided power supply board, which is going to have, you know, a higher heat requirement for actually soldering on the pins, because you got the copper content on both sides of the board. There's a beefy inductor in there. Let's see how much effort it takes to reflow solder on that big copper pad. It's going. Yep. Not bad. And we got 3 leads on a big MOSFET right here. Yep, that flowed pretty quickly. So far, so good. Let's try desoldering some. Add a little bit of fresh solder. Those are foam. That was easy. And you can see there are traces on that side of the board as well. Yep, I'm happy with that. Now for the actual reason that I bought this thing, let's try the hot air. Set for 100, and it's in standby. Pick it up. And that jumps up pretty quick. Oh yeah, that's definitely putting out some heat. Very nice. Feels pretty good in the hand. And there are some surface mount resistors on here that should be good for trying it out with. Now, I should probably put a tip on the iron first. Okay, the air tip has been secured. And the air is turned all the way up. Let's turn that down. It's got a nice even speed control. Still plenty hot. Alright, let's ramp it up. Let's go for that same 300 degrees. And this is with the airflow turned all the way down. Yeah, I'm starting to see some shiny there. Alright. Yep. And 300 degrees is basically exactly halfway up on the temperature scale. Yep, that's got no problem desoldering those. I definitely need to buy a good pair of tweezers and some solder paste. You also notice the board isn't getting crispy, which is good. It's always a pain when the resistor chip flips upside down. Nice. And just to check it out. Now it's going to bounce around a little bit because that heating element's pulsing on and off. If I crank this up, we should see the full current of the heating element when it's ramping up. Should be about now. Wow, 625 watts. Oh yeah, this thing is really blowing some smoke. Killed that. It's also worth noting that these things are glued down to the circuit board. You can kind of see the remains of the silicon chip carrier for the bridge rectifier. does seem to take a good amount of time for that heating element to cool off once it's put back in the holder. Alright, so I figured out why the transformer is always energized in this thing. It's actually part of the cooldown function for the hot air gun. So if I turn the hot air gun on 350, sleep mode, I wake it up, but then I turn it back off immediately after putting it back in the holder, it stays on until the hot air gun cools off, which is good, but it still means the transformer is energized all the time. But at least there's a reason for it. Alright, so next up, let's try something with a bit more thermal mass. This is a relay board. I'm not sure what it originally came from, but these are, beefy relays. You can see they're 40/30 amps. These are pretty sizable. Pretty sizable pads. I mean, there's a SOT23 transistor, and I've also put the big chisel type tip in, which is going to have a higher thermal mass. But yeah, that reflowed like immediately. No problems there. It takes a little bit, but it's doing it. And this is still with the iron set to 300 degrees. It seems like it might be cooling off a little bit now. I mean, really, if you're soldering anything like bigger than this, you should probably have a beefier, high thermal capacity soldering iron. Yeah, I got no complaints about that. You can also maybe improve the thermal transfer by getting some like real thin sheet metal and try and stuff it in between the heating element and the soldering iron tip. You can see I've made a mess of surface mount components I have removed from miscellaneous circuit boards. And you can get replacement tips. These things are so common now from all kinds of different vendors. You can get like a 20-pack of replacement tips for, $10. So overall, I'd say I'm pretty happy with this thing.